try and address what looks like a very simple question. But I think deeply understanding it, or not deeply understanding it, kind of makes a difference as to how well you do in algebra and really in math going forward. I say this because I think in our early math training, we're taught to just see f of x equals y as just formula. We don't really understand what f of x means. So before I kind of start on any graphing, I'm just going to treat it as an algebra question first. So I'm going to make up f of x equals x squared plus 3x minus 1. Now I just made that up, and actually I think what I'm going to do is I'm going to just treat that as just an expression right now. X squared plus 3x minus 1. And so if I said, well, what if x is 2? Well, then I would have I would have 2 squared plus 3 times 2 minus 1. So I have 4 plus 6 minus 1. And that would equal 9. That's if x was 2. Well, what I'm saying when I do this is I'm telling you that this is a function. And you can just assume that it's a function. And I'm not going to go through the definition of function right now. We know it's, for every x, there's one and only one y, the vertical line test. But all I did just a minute ago was I did this. I did f of 2 is equal to 2 squared plus 3 times 2 minus 1. I evaluated the function for 2. I evaluated the expression for the number 2. I can do the same thing in this particular case with any bunch of numbers. I can find what is f of 4. And that is equal to 4 squared, using my parentheses like I should, plus 3 times 4 minus 1. So that would be 16 plus 12 minus 1. So that would be 28 minus 1, that would be 27. So all I've done here is I've evaluated this expression for different numbers. And then in calling it a function, I told you a little bit more about it. I told you that it passes the vertical line test. I told you that for every x, there's one and only one y. I've given you some information in terms of being able to find out domain. But the key thing I want to get across right here is that all I'm doing is I'm evaluating this expression right here for various numbers. And since I can do it for any number of numbers, a whole bunch of numbers, I mean an infinite number of numbers, I write it like this. I say f of x is equal to this expression. So whatever I plug in for x here, whatever I evaluate for x, I know I just need to replace the x's in this expression and then get an answer. And that's really where we should start in our attempt to understand functions. That's all we're saying here when we say f of x. We're saying something is a function of x. In other words, the value that we're going to get right here depends on the value that we use for that x. Because that value for x, our input value, is going to go into each of these spots right there. And after we then finish evaluating this expression, we are going to have an output that we call f of x. Well, that's looking at algebraically. And fortunately for us, along came Descartes. I'm pointing to Descartes over there on my wall. He's the guy with the yellow poster. And Descartes looked at this and he said, hey, you know, I think we can do something interesting with this, which will have an impact on geometry as well. But forgetting about that, I think what we can do is we can take a two-dimensional surface, a plane, and we can call this an x-axis. So all of our x's that we're going to evaluate our f of x's with are along this axis. And what we're going to do is, after we evaluate it for x, well, whatever that number is, I think I'll plot that number also on a y-axis. So really what I have when I evaluate an expression for x, and I get an answer, I just look and say, well, what is that answer? And I put that on the y-axis, and I have a point xy, which is really the exact same thing as the point f, comma, f of x. I take the function, I evaluate it for a particular x, and I get the answer f of x. Once I get the answer f of x, I can then plot it as an ordered pair on a two-dimensional surface as the point xy. This is why we say y and f of x are the same thing. Really, if you want to look at it seriously, f of x is kind of the way we would approach it if we're just using algebra, and y is the way we approach it when we want to graph it, because I have an xy plane. I don't call it the x, f of x plane, although I could. Maybe that would have been less confusing, but that isn't the way they did it. They made it an xy plane. If you can think about this when you're doing your function problems, especially as we get to more of the calculus or pre-calculus problems, I think it's really going to help you understand what we're talking about and give us more of a grok understanding of f of x and less of just a formula understanding of f of x.